Hello everyone, welcome back to my YouTube channel. I, Mr. Yogesh, Faculty of Mathematics, and I am here to put excitement back into the education. In this lecture, we are going to discuss the chapter first from geometry, that is similarity, the questions given in case of the question bank provided by the Maharashtra State Board. We have the first question, that is the MCQ, 1 mark each question. If triangle ABC is similar to triangle PQR and AB is to PQ is equal to 3:4, then area of triangle ABC is to area of triangle PQR is equal to. We have given the 4 choice code. Among them, we have to choose correct one. Now here we have given firstly the triangle ABC, which is similar to the other triangle we have PQR. And one more thing we have given, AB is to PQ, means we have the ratio of AB and PQ, that is equals to a 3/4. Now once the triangles are similar, what about their ratio of area? So that we have the theorem, that is ratio of area of two similar triangles. Once the triangles are similar, then ratio of their area is equal to, we have the ratio of square of their corresponding sides. So that we are writing ratio of area of two similar triangle. We have here area of first triangle ABC divided by area of second triangle we have PQR, that is equals to the ratio of squares of their corresponding sides. So we have the corresponding sides AB and PQ. So square of AB divided by we have square of PQ. Once we are taking square of numerator denominator common, so that we are getting AB divided by PQ the whole square. That means once we replace now AB by PQ by their value as a 3/4, we are getting area of triangle ABC divided by area of second triangle we have PQR, that is equals to, we have a 3/4 the whole square. Once we separate the square of numerator and denominator, we are getting 3 square divided by 4 square. 3 square is 9, 4 square is 16. So that we have ratio of area of two similar triangle ABC and PQR is equals to 9 divided by 16. So that we have to evaluate here area of triangle ABC is to area of triangle PQR, that is equals to 9/16, means we have 9 is to 16. So look at the choice codes among the given. We have the correct choice code is 9 is to 16, means the choice code B. Now look at the second MCQ. Which of the following is not a test of similarity? So we have, there are 4 tests of similarity. First is the angle test. That means once the 3 angles of a first triangle are congruent to corresponding 3 angles of the other triangle, then the triangles are said to be similar by using angle test. Second test of similarity of triangle, we have a angle test. Once any 2 angles of the first triangle are congruent to corresponding 2 angles of the other triangle, then the 2 triangles are said to be similar by using angle test. Now the third test we have side test. Once any 2 sides of the one triangle are in proportion with the corresponding 3 sides of the other triangle and their included angle are congruent, then we can say that given 2 triangles are similar by using side test. And the last test we have the side test. That means the 3 sides of the one triangle are in proportion with the corresponding 3 sides of the other triangle, then the 2 triangles are said to be the similar by using side test. So we have the angle test, we have the side test, we have the side test. So which is not a test of similarity, that is the choice code C, side angle test. Now look at the third MCQ. We have, it is of the form if triangle XYZ is similar to triangle PQR, area of triangle XYZ is 25 centimeter square, area of triangle PQR is 4 centimeter square, then XY is to PQ is equal to. We have given the 4 choice code, among them we have to choose the correct one. So here we have given the two triangles, first triangle is the XYZ and the other triangle we have PQR. The given two triangles are similar. Now once the triangles are similar, then what about their ratio of area? So we have by ratio of area of two similar triangle theorem. What we have? As per the theorem, area of triangle XYZ divided by area of triangle we have, other triangle is the PQR, that to be equals to the ratio of squares of their corresponding sides. Now XY corresponds to PQ, so that we are taking XY square divided by PQ square. Now we have here area of triangle XYZ is 25, while area of triangle PQR is 4. So 25 divided by 4, that is equals to XY square divided by PQ square. Now to evaluate the value of XY divided by PQ, taking square root on both sides, 25 is a square root, we have a 5, 4 square root we have a 2. That means at last we are getting XY is to PQ, that is equals to we have 5 is to 2. Now look at the choice codes, among them correct choice code is C, 5 is to 2. Look at the sub question 4, ratio of areas of two similar triangle is 9 is to 25, dash dash is the ratio of their corresponding sides. Once keep in mind, once we have to evaluate here the ratio of the sides, we have to take the square roots, and once we have to evaluate the ratio of area of two similar triangle, at that time we have to evaluate the squares. So that we are assuming we have the two similar triangles, triangle ABC and triangle PQR. We have given area of triangle ABC divided by area of triangle PQR, that to be equals to 9 divided by 25. We have to evaluate the ratio of their corresponding sides. So we have the theorem, ratio of area of two similar triangle. By using this theorem, we may write now the area of first triangle ABC divided by area of second triangle we have a PQR, that to be equals to the ratio of squares of their corresponding sides. So AB corresponds to PQ, so that we are getting AB square divided by PQ square. We may write BC corresponds to QR, so we may have BC square divided by the QR square, or we may have AC corresponds to PR, so AC square divided by PR square. So that we have given here ratio of area is 9 divided by 25, that to be equals to, now we are having AB square divided by PQ square, or we might have BC square divided by QR square, or we might have here AC square divided by PR square. Now to evaluate ratio of their corresponding sides, we have to take the square root on both sides to cancel out the squares. So after all taking the square root on both sides, we are getting ultimately AB divided by PQ equals to BC divided by QR equals to AC divided by PR, that to be equals to square root of 9 is 3, square root of 25 is 5. So that corresponding sides are is in the ratio 3 by 5 means we are having 3 is to 5. Look at the choice code, we have the correct choice code is B, that is 3 is to 5. Look at the fifth question. Given triangle ABC is similar to triangle DEF, if angle A equals to 45 degree, angle E equals to 35 degree, then angle B is equals to. So here we have given there are the two triangles. Suppose we are having the triangle ABC be the first triangle, and other triangle we have, let us DEF. So here A corresponds to D, B corresponds to E, C corresponds to F, so that D, E, F be the triangle. Among them we have given angle A to be equals to 45 degree and angle E to be equals to we have 35 degree. We have to evaluate the angle B. So once here we have given triangle ABC is similar to triangle DEF. So we well known once the triangles are similar, their corresponding sides in equal proportion while their corresponding angles are equal. Here we require to evaluate the value of an angle B so that once the triangles are similar, we can say that here corresponding angles are congruent. Angle A congruent to we have angle D. Angle B is congruent to we have angle E. Keep in mind congruent means they are having the equal measures. And at last we have angle C is congruent to an angle F. So here we have given measures of an angle E is 35 degree. E is the same as that of an angle B or B is same as that of an angle E. Here we have to evaluate an angle B. So angle B is equals to we have a E. Once the angles are congruent means they are having the equal measures. And angle E value we have given 35 degree. So that we have measures of an angle B to be equals to again a 35 degree. So look at the choice code. We have the correct choice code is choice code B as a 35 degree. Now look at the sixth question. We have it is of the form. In the figure, segment DE is parallel to segment BC. Look at the DE and the BC. Identify correct statement. Now we have given the segment AD, DB, AE and EC's are ratio. So that here once we are having the segment, I am writing in triangle, we have a ABC. Segment DE is parallel to the third side of the triangle, that is the segment BC. Segment DE intersects the one side AB of a triangle in point D and segment DE intersects the other side AC in point E and parallel to the third side of the triangle. That means here we have to use the basic proportionality theorem. So I am writing by basic proportionality theorem. What we have by using the basic proportionality theorem, whatever be the segment made on the AB and the AC due to the DE that are in equal proportion. Which segments we are having? AD, DB made on AB and AE and EC made on AC. That means that are in equal proportion. We are having AD divided by DB, that to be equals to AE divided by EC. Look at the choice code. Among the given we have the correct choice code is D. AD divided by DB is equals to AE divided by EC. Look at the question number 7. We have if triangle XYZ is similar to triangle PQR, then XY divided by PQ is equals to YZ divided by QR is equals to. We have given the 4 choice code. Among them we have to choose the correct one. So here triangle XYZ which is similar to triangle PQR. So look at the vertex correspondence of triangle XYZ and the PQR. X corresponds to we have P, then Y corresponds to we have Q and Z corresponds to R. You may have the figure here for the given triangle. Suppose to be we have the triangle XYZ and the other triangle we have the PQR. X corresponds to we have P, Y corresponds to Q and Z corresponds to R. So once the triangles are similar, then their corresponding sides are in equal proportion. That means we are having XY divided by PQ, that is equals to YZ corresponds to we have now the QR. So YZ divided by QR is equal to we have a XZ divided by which is corresponds to PR. So we have given XY divided by PQ is equals to YZ divided by QR is equal to we have a XZ divided by PR. Look at the choice codes. We have the correct choice code is A, XZ divided by PR. Look at the 8th question. We have if triangle ABC is similar to triangle LMN and angle A equals to 60 degree, then angle L equals to. We have the 4 choice code. Among them we have to choose the correct one. So that we have there are the two triangle ABC and the triangle LMN which are similar. So let's figure out the question first. We have there are the two triangles. First triangle is the triangle ABC. Second triangle is the LMN. Keep in mind here vertex A corresponds to L, B corresponds to M, C corresponds to we have a N. Now among them we have given angle A becomes 60 degree. So once the triangles are similar, then their corresponding angles are congruent. That means we are having the corresponding angles are of the form angle A and angle AL, those are congruent. Next angle B and angle M, those are congruent, and C and next to it which is corresponds to an angle N, so angle C and angle N are congruent. Congruent means they are having the equal measures. So here once we are having angle A is congruent to an angle L, means those are having the same measures, angle A equals to angle L, and angle A value already we have given 60 degree, so that should implies now the measures of an angle L is equal to we have 60 degree. Look at the choice code, we have the correct choice code is choice code B. Look at the question number 9, we have given in triangle DEF and triangle XYZ, DE divided by XY is equals to FE divided by YZ, and angle E is congruent to an angle Y, dash dash test gives the similarity between triangle DEF and triangle XYZ. Look at now we have given the ratio of corresponding sides are in equal proportion. Which two sides we have here? DE and XY, that is equals to FE and the YZ. So those two sides are ratio in equal proportion, and we have an angle E is congruent to an angle Y. So we have the ratio of the sides DE and the EF, whose included angle we have an angle E. What is mean by included angle? The angle formed by the side DE and the EF, it is known as the included angle of segments or the sides DE and the EF, that is an angle E. While we have the XY and the YZ, so that their included angle we have an angle Y. So once the two sides of a triangle are in equal proportion and their included angle is congruent, then we can say that given two triangles are similar, that means triangle DEF is similar to triangle we have XYZ. By the test we can say side angle side test. So look at the choice codes. We have the correct choice code is B, side angle side means SAS test. Look at the next and the last MCQ number 10 we have. In the figure BD equals to 8, BC equals to 12, point of collinearity holds between BD and C, B after D after C, then area of triangle ABC divided by area of triangle ABD is equals to. We have the four choice code. Among them we have to choose the correct one. We have given the value of BD is 8 while BC is we have a 12. Now once we have here in triangle ABC and the ABD, vertex A and vertex B are the common vertices. So once we draw the perpendicular from vertex A on its opposite side, let us we have AE be the perpendicular on BC. Then we may have at start for a triangle ABC, we are writing the base and the height of the triangle, because to evaluate the area of any triangle ABC we have the formula half times base into height. So let us try to have firstly the base and height of the triangle ABC. Once AE is the perpendicular drawn on which side of triangle, that is BC, so BC is the base and perpendicular itself as a height. Now look at the second triangle, we have the triangle ABD. For triangle ABD we are writing base and height. Look at the triangle ABD carefully, this type of triangle we have. Now it is an obtuse angle triangle. Once we draw the perpendicular from point A on its opposite side, that is BD, so that means we are having now AE be the perpendicular on extended BD. That means AE is the height drawn on extended BD, so BD is the base. So we are writing BD is the base and AE is the height. Now we well known ratio of area of any two triangle. We are talking about any two triangle, that is the triangle ABC and triangle here ABD, is equals to the ratio of product of their bases and height. So for the first triangle ABC we have the base is BC and height is AE. For the second triangle we have base is BD and height is AE. Now those two triangles are having the same height, so height and height, that means the A and AE getting cancelled from numerator denominator. We can say that the ratio of now those two triangles is equals to ratio of their bases. Try to replace the value BC, we have a 12 and BD we have a 8. Now we well known 4 2s are 8, 4 3s are we have a 12. So ratio of area of triangle ABC and the ABD we have 3 divided by 2. That means we can write it is of the form 3:2. Look at the given choice code. Correct choice code, we have the choice code B, 3:2. Now look at the question first B. Each of 1 mark questions we are having. Within it the first question, are the triangles in the figure similar? If yes, then write the test of similarity. Look at the triangle, we have triangle ABC and PQR. Length of AB is 6 unit, BC is 8 unit, AC is 10 unit. Length of PQ is 3 unit, QR is 4 unit, PR is 5 unit. Now once we have given the values of all three sides of respective triangles, so try to evaluate ratio of sides of triangle. That means AB now corresponds to we have the PQ. So try to evaluate AB divided by we have the PQ, that is equals to value of AB is 6, PQ is 3, 3 1s are 3, 3 2s are 6, so that we are getting AB divided by PQ is equals to a 2. Now try to evaluate the ratio of corresponding sides. Other side we have BC which is corresponds to QR, so BC divided by QR is equal to value of BC is 8 and QR is 4, again 4 2s are 8, we are getting B is equal to 2, called it as equation number 2. Try to evaluate the third corresponding sides are ratio. AC corresponds to we have the PR, so AC divided by PR is equal to 10 divided by 5, 5 2s are we have a 10, called it as now the equation number 3. Now be careful about the equation 1, 2 and 3. All three equations are having the same LHS, so that we are writing for equation 1, equation 2 and equation 3. Once all three equations are having the same RHS as a 2, 2 and 2 respectively, so that we can equate their LHS. So that should implies now AB divided by PQ, that is equals to we have BC divided by QR, that is equals to we have a AC divided by PR. Once the three sides of a one triangle is in equal proportion with the corresponding three sides of the other triangle, then we can say that given two triangle, that is ABC and triangle PQR, are similar by which test? By side test. In short, we may write it as a SSS test. Look at now the second question. It is of the form, in the figure line BC is parallel to line DE, AB equals to 2, BD equals to 3, AC equals to 4, CE equals to X. Then find the value of X. Look at the triangle, we have the triangle ADE in which line BC is parallel to DE. So once we have given here line BC is parallel to, we have a line or the side or the segment DE. So we can use here by basic proportionality theorem. What we have as per the basic proportionality theorem, we can write whatever be the segment made on AD and CE by BC that are in equal proportion, that means AB divided by BD is equals to AC divided by CE. So that I am writing AB divided by BD, that is equals to now we have AC divided by CE. Try to replace by their value. As per the given data, we have the value of AB is 2, BD is 3, AC is 4 and CE is X. So that should implies now 2 divided by 3, that is equals to AC is 4, CE is x, we are getting 4 by x. Now to evaluate the value of x, what shall we have to do? Shift x as well as 3 from RHS to LHS, LHS to RHS respectively. Divisor becomes multiplied to whom? To 2. That means we are getting 2 into x, that is equals to, divisor becomes multiplied to whom? To 4. That means we are getting 4 into 3. Now 2 into x means the 2x, that is equals to 4 3s we have a 12. Divide both sides by 2, or you may shift the 2 from LHS to RHS, so that the value of x is 2 is a multiplier after all shifting divisor. We well know now 2 6 are 12, that means the value of x is, we have a 6. Now look at the question number 3. State whether the following triangles are similar or not. If yes, then write the test of similarity. We have given angle P equals to 35 degree, so that I am writing value of an angle P equals to 35 degree on the figure. Angle X is equals to 35 degree, so that angle X is equals to, we have 35 degree. Next to it, angle Q equals to 60 degree, so that we are having angle Q equals to 60 degree, and angle Y equals to, we have 60 degree, so that I am writing on the figure angle Y to be equals to 60 degree. So look at here, we have, there are the two triangle. First triangle is the PQR, and other triangle we have the XYZ. So is in the given triangle, we have angle P is equal to the angle X. That means we can say angle P is congruent to an angle X, because both of measures we have 35 degree. Next to it, once we have given angle Q equals to 60 degree and angle Y equals to 60 degree, both are having the equal measures, that means they are congruent. Angle Q is congruent to an angle Y, we have both are 60 degree. Now once the two angles of one triangle, that are P and Q, are congruent to the corresponding two angles of the other triangle, that are angle X and angle Y, so that we can say the given two triangle PQR and the XYZ are similar by angle test. Once we are choosing the two angle of one triangle are congruent to the corresponding two angles of the other triangle, that means we are having here angle test. In short, we may write it as a AA test. Now look at the question number 4. It is of the form, if triangle ABC is similar to triangle LMN, angle B equals to 40 degree, then angle M is equals to, give reason. So that here we have, there are the two triangles again, ABC and the triangle LMN, that are similar. So let's have figure out the question first. Triangle ABC and we have the other triangle. Let us consider ABC and the LMN be the triangle. We have given angle B equals to 40 degree, and now we well known, once the triangles are similar, then their corresponding angles are congruent. So angle B is congruent to an angle M, both are having, we have the same measure, that is 40 and 40 degree each. So that once the triangles are similar, that should implies we have to evaluate for M, we have given the value of an angle B, so that we are writing one pair of corresponding angles to be congruent. That means we can say here required angles are only B and M. So let's have angle B is congruent to an angle M. Why? Reason behind it, corresponding angles of similar triangles. This is the reason behind it. So that once the triangles are congruent means they are having the equal measure. Angle B equals to angle M is equal to, we have angle B is 40 degree, so that value of an angle M we have again the 40 degree. So hence we have value of an angle M equals to 40 degree. Now look at the question number 5. Areas of two similar triangles are in the ratio 144 is to 49. Find the ratio of their corresponding sides. So let us try to consider, we have the two triangles are of the form triangle ABC and triangle PQR. Those two triangles are similar. So once the triangles are similar, what about their ratio of areas? So that we are using here ratio of area of two similar triangle theorem. So what does the theorem told us? Once the triangles are similar, then ratio of their area means the area of triangle ABC divided by area of triangle PQR, that is equals to the ratio of squares of their corresponding sides. So now AB corresponds to PQ, so that AB square divided by PQ square. We may write that to be equals to either a, now we are taking BC whose corresponding side we have the QR. So BC square divided by we have the QR square, and we might take the third side, that is AC. So AC and corresponds to we have the PR, so that we are getting AC square divided by the PR square. Now once we have the area of triangle ABC is to area of triangle PQR is 144 is to 49, so that we are able to write now AB square divided by PQ square is equal to BC square divided by QR square equals to A. We have the PR square, and that to be equals to ratio we have given 149 is 144 is to 49, means 144 divided by 49. Now we have to evaluate ratio of their corresponding sides, that means AB by PQ, or might be BC by QR, or might be AC by PR. So that taking square root on both sides, we are getting AB square divided by PQ square is a square root AB by PQ, that to be equals to BC square divided by QR square is a square root BC by QR, and nextly we have the AC by PR, that is equals to square root of 144 is 12 and square root of 49 we have a 7. So the ratio of corresponding sides we have 12 is to 7 here, that means the 12 by 7. Now look at the question number 6. Triangle PQR is similar to triangle SUV. Write their pair of congruent angles. So that here we have given triangle PQR is similar to triangle SUV. Look at the vertex correspondence first. Vertex P corresponds to vertex S. Vertex Q corresponds to vertex U. And at the end, vertex R corresponds to vertex V. Let's have the two similar triangle first. Suppose to be we are having first triangle be the triangle PQR is of the form, and next triangle we are having SUV is of the form. P corresponds to S, Q corresponds to U, R corresponds to V. Now once the triangles are similar, then we have corresponding angles are congruent. So angle P corresponds to angle S, those are congruent. Angle Q corresponds to angle U, those two pairs of angles are congruent. And angle R corresponds to an angle V, so angle R is congruent to we have a V. So now once the triangles are similar, we are having corresponding angles are congruent, so that angle P congruent to an angle S, angle Q congruent to an angle U, and at the end angle R is congruent to an angle V. Reason behind it, those are now the corresponding angles of similar triangles. Now look at the question number 7, which is same as that of the question number 6. Is in the question number 6 we have to write the pair of corresponding angles, and here we have to write the ratio of their corresponding sides once the triangles are similar. Triangle ABC is similar to triangle DEF. Write the ratio of their corresponding sides. So once we have the triangle ABC, which is similar to triangle DEF, that means vertex A corresponds to D, B corresponds to E, and C corresponds to F. So let's have the two triangle first. Suppose to be we have the first triangle ABC is of the form, and the second triangle DEF is of the form. A corresponds to vertex D, B corresponds to E, C corresponds to F. Now once the triangles are similar, then their corresponding sides are in equal proportion. That means we can say now AB divided by we have the corresponding side of AB is DE. Next to it BC divided by EF, so that to be equals to now BC divided by we have the EF, Next corresponding side we have the AC and the DF. So that to be equals to we have AC divided by DF. Why it is so? Because those are the corresponding sides of similar triangle. Hence we have ratio of their corresponding sides here is of the form AB divided by DE is equals to BC by EF is equals to AC divided by DF. Look at the question number 8. We have given the triangle. In the figure, TP equals to 10 centimeter, PS is equals to 6 centimeter. We have to evaluate now area of triangle RTP divided by area of triangle RPS. Now once we have the vertex R is common in case of the RTP be the this one triangle and RPS be the this one triangle, this blue shaded triangle. So once we draw the perpendicular from point R on its opposite side TS, let us we are assuming RA now be the perpendicular on side we have the TS. That means ultimately the segment RA is perpendicular on the side TS. We have to evaluate here area of triangle RTP divided by area of triangle RPS. Now we well known for finding the area we have the formula half times base into height. So look at the first triangle, we have the triangle RTP. So what about the base and the height of respective triangle RTP? Once here RA be the perpendicular drawn on extended triangle RTP is an obtuse angle triangle. That's why we are drawing the perpendicular on extended TP here. So that RA be the perpendicular drawn on the TP. So TP be the base of the triangle and perpendicular itself as a height of triangle. So that base is TP and height is we have the RA. Now look at the second triangle. We have the triangle RPS. So for RPS, which is your base and which is your height. So here RA be the perpendicular drawn on the PS. That means PS be the base and the perpendicular itself as a height of the triangle. Now once we are evaluating the ratio of area of two triangles, that to be equals to we have the ratio of product of their bases and the height. That means we have now for the triangle RTP, TP be the base and height becomes the RA. Product means the multiplication of base and the height. RPS means we have for the triangle RPS, base is the PS and height is the RA. That means here those two triangles are having the same height, that is RA getting cancelled. That means we can say is that ratio of area of given two triangle once they are having the same height is proportion to ratio of their bases. That means TP divided by we have the PS. Value of the TP already we have given 10 centimeter and value of the PS we have the 6. Now we well known 2 5s are 10, 2 3s are 6. So that we have here area of triangle RTP divided by area of triangle RPS, that is equals to we have 5 divided by 3. Now look at the question number 9. We have given ratio of corresponding sides of two similar triangle is 4:7. Then find the ratio of their areas. So that let us assume that we have there are the two triangle ABC and triangle PQR. We have given those two triangles are similar. Once the triangles are similar, their sides are in equal proportion. That means AB divided by PQ is equal to, we can write BC divided by QR is equal to AC divided by PR. And this ratio we have given 4:7 means 4/7. Corresponding sides of two similar triangle R is in the ratio 4:7 means the 4/7. Now once we have to evaluate the ratio of their areas, so that we are using here theorem ratio of area of two similar triangle theorem. What we have as per the theorem, ratio of area of two similar triangle, that means area of triangle ABC divided by area of triangle PQR, that to be equals to ratio of squares of their corresponding sides. We may choose any one side. AB corresponds to now PQ, so that we are having AB square divided by PQ square. Once we are taking square of numerator denominator common, so that we have AB divided by PQ the whole square. So that area of triangle ABC divided by area of triangle we have PQR, that to be equals to, now AB divided by PQ is 4 by 7, so 4 by 7 the whole square. Once we separate the square of numerator and denominator, so that we are getting 4 square divided by 7 square. Now we well known 4 square is 16 and 7 square is 49. So ratio of area of two similar triangle, we have a area of triangle ABC divided by area of triangle PQR, that to be equals to 4 square is 16, so 16 divided by 49. Now look at the next and last question from question first B. 1 mark each question we are discussing. Write the test of similarity for triangles given in the figure. We have there are the two triangles. First triangle is ABC. Second triangle is PQR, in which angle B is 60 degree, angle C is 30 degree. Is in the triangle PQR. Angle Q is 60 degree and angle R is 30 degree. So that I am writing at start, we are having angle B is equal to angle Q. Both are 60 degree as per the given. Next, we are having angle C to be equals to angle R. Both are to be 30 degree as per the given. So that we may call them as a equation 1 and 2. Now let us try to consider the given triangle, triangle ABC and triangle PQR. Is in the triangle we have angle B is congruent to an angle Q. From equation we are writing 1. Once the given two angles are having the same measures, then we can say that they are congruent. Equal means the congruent here. Now we can write as per the equation 2, angle C is congruent to an angle R because both are having the same measures as per the equation number 2. Now once the two angles of one triangle are congruent to corresponding two angles of the other triangle, then we can say that given two triangles are said to be similar. But once we are showing the angle is congruent to the other angle and we have the angle is congruent to the other angle, so that means we are using here angle test. In short, we may write it as a AA test. Now we are going to discuss the 2 marks question which are asked is in the question 2A activity based and question 2B as a solving. Look at the question 2A, complete the activity. 2 mark questions we are having. We have given the triangle ABC. In the figure, BP is perpendicular to AC. So this is the segment BP which is perpendicular on AC. So we are putting the perpendicularity symbol. Next to it, CQ is perpendicular to AB. Look at the CQ which is perpendicular on AB. Now we have the point of collinearity A after P after C. That means point A, P and C are collinear and AQB are collinear. Then show that triangle APB and triangle AQC are similar. So in the triangle APB, look at the triangle APB, we have this one triangle and a red shaded triangle, that means, and the triangle AQC, that is the blue shaded triangle. We have is in the given triangle angle APB which is 90 degree. Once the segment BP is perpendicular on AC, we have the angle APB that is equals to 90 degree. While once the segment CQ is perpendicular on the AB, so that we have angle AQC that to be equals to again a 90 degree. Now look at the next statement. We have given angle, that means once they are having the same measures, so that we can say the angle APB is congruent to an angle AQC. Now look at the angle A. which is the common angle in both the triangle. So by the property of reflexivity under mathematics, we can say that the angle we are having first for the first triangle, that is PAB, which is congruent to an angle, have angle A for the second triangle, that is QAC. Once those two angles are congruent, which property we are having here, the common angle. Angle A is common for both the triangle. So once the one pair of corresponding angle is congruent and the other pair of corresponding angle are congruent, we can say that given two triangles are congruent by, I am writing angle test. Hence we have here the first activity. Now look at the second activity. We have given observe the figure and complete the following activity. In the figure, angle B equals to 75 degree. Angle D equals to 75 degree. Angle B is congruent to an angle. Once the two angles are having same measures, that means equal in measures, we can say that the angles are congruent. So angle B is congruent to an angle D. Now look at the triangle. Overall triangle we have the ABC, and the triangle we have the red shaded triangle EDC. In it we have angle B is congruent to angle D, each of 75 degree measures. Now those two triangle ABC and the EDC having one common angle, that is the angle C. So by the property of reflexivity under mathematics, angle C is congruent to itself C. Why? Because we are having here the reason behind it, common angle. Now once the two corresponding angles are congruent and other pair of corresponding angle is congruent, so that we can say the given two triangles are said to be congruent. Which two triangles here we have? One is the ABC, other is the triangle EDC. Those two triangles are congruent by using angle test of similarity. Hence here we have here second activity. Now look at the next activity. We have the activity number 3. Triangle ABC is similar to triangle PQR. Area of triangle ABC is 80 square centimeter. Area of triangle PQR is 125 square centimeter. Then complete. We have given ratio of area of two similar triangle. Area of triangle ABC divided by area of triangle PQR, that is equals to 80 divided by we have 125. That to be equals to. Now look at the required sides ratio we have AB and PQ. So once the triangles are similar, then ratio of area of two similar triangle is equals to, we have ratio of square of their corresponding sides. So which corresponding sides we required? AB and the PQ are the corresponding sides. So that we are having AB square divided by here PQ square. Now we are evaluating the sides of the triangle, ratio of sides of the triangle. So that taking square root on both sides, we are getting AB divided by PQ, because square we have square root of AB square is AB, square and square root getting cancelled, and square root of PQ square and square root getting cancelled, we have the PQ, that is equals to square root of 80 divided by we have a 125. So now we well known 16 5s are we have a 80 and 25 5s are we have 125. Now once we separate the square root of numerator and denominator, so that square root of 16 we have a 4 and square root of 25 we have a 5. So AB divided by PQ we are getting 4 divided by a 5. Hence we have here third activity from question 2A. Now let's have a look over question 4, activity based question we have given again. In the figure, PM equals to 10 centimeter. Area of triangle PQS is 100 square centimeter. Area of triangle QRS equals to 110 square centimeter. Then NR equals to. We have here triangle PQS and triangle QRS. Identify the triangle from the given quadrilateral. We have the PQS be the upper side triangle, red shaded triangle, and QRS be the lower triangle, that is the green shaded triangle. Having segment QS be the common segment. That means both the triangle, once we are thinking over the upper side triangle, PM be the perpendicular drawn on the QS. So QS be the base and PM be the height of triangle PQS. And once we have a look over the lower triangle, that is the QRS, RN be the perpendicular drawn on the QS. So QS be the base and NR be the height of the triangle QRS. So those two triangles are having the common base or the same base, that is the QS. So that we can write here area of two triangles whose base are common are in proportion of their corresponding. Now once the bases are same, so area is proportion to their corresponding heights. So that we are having here area of triangle PQS divided by area of triangle QRS, that to be equals to, we have the first triangle, that is the PQS upper side triangle, whose height we have the PM, and lower triangle we have the QRS whose height we have the NR. So PM divided by NR. Now area of triangle PQS we have given 100, area of triangle QRS we have given 110. That is equals to, we are getting first triangle's height becomes the PM. So PM divided by, we have here the NR. So now we have here NR to be equals to, once we shift the NR, we have 100 divided by 110, that is equals to PM divided by NR. Once we shift the NR from RHS to LHS, divisor becomes the multiplier. Multiplier to whom? To 100. So that we are getting 100 times NR, that to be equals to, simultaneously once we shift the 110 from LHS to RHS, 110 is the divisor. After all shifting, it will becomes the multiplier to PM. So now we have to evaluate the value of NR here. So that we try to shift here 100 from LHS to RHS. 100 is the multiplier. After all shifting, it will becomes the divisor to 110. So that we are getting 110 divided by 100 times the PM be the value of NR. Now here already we have given the value of PM is 10. So you may replace is in the same step the PM by its value, that is 10. So that we are having 10 ones are 10, 10 tens are 100. Now we remained with the 110 divided by 10. 10 11s are, we have 110. So the value of NR we are having here 11 centimeter. Hence here we have all four activities given in case of the question bank, question 2A. Now look at the question number 2B. We have a 2-mark question. First question is of the form, in the figure AB is perpendicular on BC and DC is perpendicular on BC. AB equals to 6, DC equals to 4. Then we have to evaluate area of triangle ABC divided by area of triangle BCD. Now look at the triangle ABC, which is your base and height for the given triangle. Once we assumed here the perpendicular, that is we are having AB drawn on BC, so BC becomes base and the perpendicular AB becomes the height of the triangle ABC. Now for the next triangle we have BCD. Once we assumed DC be the perpendicular drawn on the BC, so that the BC is base and the perpendicular, that is DC, is the height of the triangle. Now we have to evaluate here the ratio of area of triangle ABC to that of triangle BCD. Once the given two triangles having same base, then ratio of their area is equals to the ratio of their corresponding heights. We have for triangle ABC height is AB and for triangle BCD base is, sorry for that, height is we have DC. So the AB value we have 6 and the DC value we have 4 unit. Now we well known 2 2s are 4, 2 3s are 6, so that we can able to write here area of triangle ABC divided by area of triangle BCD, that is equals to we have 3 divided by 2. Hence we have the first question. Now look at the question second. We have in the figure segment AC and segment BD intersects each other in point P. AP divided by PC is equals to BP divided by PD. Then prove that triangle ABP is similar to triangle DPC. Look at the triangle first. We have the APB with the uppermost triangle and DPC with the lowermost triangle. We have given AP divided by PC. That means this as a AP divided by we have the PC. That to be equals to we have the BP divided by DP. That means the corresponding sides of given triangle are in proportion. Two corresponding sides are in proportion. Once we have here AC and BD intersects in point P, so the vertically opposite angles are formed and that are congruent. So we can say that the DPC is congruent to an angle we have BPA. So that I am writing at start in triangle ABP and a triangle we have DPC. As per the given data, we have a AP divided by PC, that is equals to BP divided by PD. This is given to us. And we have an angle first, that is we are taking APB, which is congruent to an angle we have CPD. Why those two angles are congruent? Because those are vertically opposite angles. So the two pair of corresponding sides of given two triangle are in proportion and their included angle is congruent, so that we can say given two triangle ABP and the triangle DPC are similar by side angle side test. In short, we may write it as a SAS test. Hence we have the second question. Now look at the question number 3. We have triangle ABP, which is similar to triangle DEF, and area of triangle ABP is to area of triangle DEF is equals to 144 is to 81. Then AB is to DE is equals to. So now we are writing firstly the given data. We have the two triangle. One is the triangle ABP and other is the triangle DEF. Those two triangles are similar. Now once the triangles are similar, then we are using now to find the ratio of area of two triangles, so that we have ratio of area of two similar triangle theorem. As per the theorem, once we have the triangles are similar, then ratio of area of two similar triangle means area of triangle ABP divided by area of triangle DEF, that to be equals to we have the ratio of squares of their corresponding sides. We have AB be the one side whose corresponding side we have the DE, so that we are taking the squares of them and ratio. So AB square divided by we have DE square. Once we have now area of triangle ABP is to DEF is equals to 144 is to 81, so that we are getting ratio of area of triangle ABP to the area of triangle DEF is equals to 144 divided by 81. That is equals to we are having AB square divided by DE square. Now once we are evaluating the ratio of corresponding sides of similar triangle, so at that time we have to take now the square root on both sides. Once we take the square root on both sides, square root of AB square is AB, square root of DE square is DE, is equals to square root of 144 is 12, while square root of 81 we have a 9. So that we can write now the AB is to we have DE, that is equals to 12 by 9 means we have 12 is to 9. Hence we have our third question. Now look at the question number 4 from second B. From the given information, is PQ parallel to BC? We have AP equals to 2, PB equals to 4, AQ equals to 3 and QC equals to 6. So let's have the given data on the figure. AP value is 2, PB is we have a 4, AQ is 3 and QC equals to we have a 6. Try to evaluate the ratio of the segments made by PQ on the side AB as well as the AC of given triangle ABC. That means we are finding AP divided by firstly the PB, that is equals to we have 2 divided by 4, 2 ones are 2, 2 twos are 4, so that we have a half, called it as equation number 1. Now let us try to evaluate AQ divided by the QC. We have AQ divided by QC is equal to AQ is 3, QC is 6, 3 ones are 3, 3 twos are 6, so that again we have the value is half. Look at now the equation 1 and 2 carefully. Those two equations are having same RHS, so that from equation 1 and equation 2 having the same RHS, that means we can equate their LHS. We are getting AP divided by PB, that is equals to AQ divided by QC. Now once whatever be the segment made by the PQ on the AB and the AC are in equal proportion, so that by I am writing converse of basic proportionality theorem, what we have here, once the segments are in equal proportion, we can say the line PQ which is parallel to the side of the triangle, that means the third side of the triangle, that is BC. Hence we have our proof here. Now look at the question number 5. Areas of two similar triangles are 225 square centimeter and 81 square centimeter. If side of a smaller triangle is 12 centimeter, find the corresponding side of major triangle. So let us assume that first triangle we are having whose area is given, that is the triangle ABC, and we have area of the triangle now ABC is equals to 225 centimeter square, and the other triangle we are assuming PQR, so whose area we have triangle PQR's area 81 square centimeter. If side of a smaller triangle, so look at the areas of the triangle, 225 area of ABC and area of PQR we have the 81. So compare the areas of the given triangle. We have 81 is less than that of 225, that means our smaller triangle is the PQR whose side we have given. So let us assume now first come first served, PQ be the first side, so that assume that PQ to be equals to we have here 12 centimeter. We have to evaluate the corresponding side of major triangle be the triangle ABC. So PQ's are corresponding side we have the AB, that means here we have to evaluate the value of AB. Now we have given the triangle ABC and a triangle PQR are similar, so that we can use here theorem, that is ratio of area of two similar triangle theorem. What we have as per the theorem, look at once carefully. Ratio of area means the area of triangle ABC divided by area of triangle PQR, that is equals to the ratio of squares of their corresponding sides. So once we are taking AB whose corresponding side we have the PQ, so that here we have ratio of area of two triangle, that to be equals to we are getting AB square divided by PQ square. Now replace the known values. We have triangle ABC's area 225 divided by area of triangle PQR we have the 81, that to be equals to value of AB we have to find, so that keep AB square as it is, and value of PQ we have given 12, so that we are getting 12 square. We have to evaluate here value of AB. So for finding the corresponding sides of the similar triangle, here we have to take the square root on both sides. So AB squares are square root we have the AB, 12 squares are square root we have the 12, 225s are square root we have a 15, while 81 are square root we have a 9. Now to evaluate the value of AB, try to shift now 12 from LHS to RHS so that we are getting AB to be equals to 15 into 12 divided by 9. Now we well known 3 3s are 9, 3 5s are 15 and 3 1s are 3, 3 4s are 12. So that will remain with the 5 into 4 divided by 1 means 5 into 4 is we have a 20. Unit is centimeter. So that we may have our final answer in terms of therefore the length of corresponding side of major triangle is we have here 20 centimeter. Hence we have the fifth question. Now look at the next and last question from 2B. Question number 6. From the adjoining figure, angle ABC is 90 degree. Look at the angle ABC. It is a 90 degree. Then angle DCB equals to we have the 90 degree. Look at the angle DCB. We have it is a 90 degree. Then AB equals to we have a 6 and DC equals to we have a 8. Then area of triangle ABC divided by area of triangle BCD is. Look at firstly the triangle ABC. Once we assume that for a triangle ABC, AB be the perpendicular drawn on BC. So BC is the base of the triangle and AB be the height of the triangle. Look at the second triangle. We have the triangle DCB. So in that triangle, once we assume here DC be the perpendicular drawn on BC. So BC is the base and DC is the height. Now once those two triangles are having the same base, so that we are writing once the triangle having same base, what about the ratio of their area? The ratio of their area is proportion to ratio of their corresponding heights. That means AB and DC. So that we can write area of triangle ABC divided by area of triangle we have BCD, that to be equals to now height is AB for triangle ABC and height is DC for triangle BCD. AB value we have a 6, DC value we have a 8. Now we well known 2 3s are 6, 2 4s are 8. So that we have the ratio 3 by 4. So we may write area of triangle ABC divided by area of triangle we have BCD, that to be equals to now we have 3 by 4. Hence we have our answer here. So today we will stop here. During the next lecture we are going to discuss question number 3A and 3B from same chapter, that is first chapter from geometry similarity, from the question bank provided by Maharashtra State Board. Thank you.